Hey folks, I've got an example involving friction and a pulley system. Let me explain the picture. You've got an M1 up in the table, like they say it's a book, let's say, and there's going to be a coefficient of kinetic friction between the book and the table. And then you have some block hanging over the edge of the table, and they're attached via this red string and the pulley system that I've got drawn there. And what we're going to do is we're going to just set up the equations you would use to figure out the tension in that red string and also the accelerations of the book and the block. If you need a moment, go ahead and sketch that diagram out. All right. So in order to do this problem, you gotta be careful with both your FBDs and also with well, you kind of have to just look at the situation. So let's talk about the accelerations of the two objects. Okay. When M2 drops, let's say 1 foot, how far will M1 have moved? Okay. Well, it turns out it's not a foot. Okay. This string, the string, let's say from this pulley, let's measure from that pulley. This part of the string will have gotten longer by a foot. That means this entire part of the string will have gotten shorter by a foot. But what that also means is this part of the string and this part of the string will only have gotten shorter by half a foot. So M1 is only going to move half a foot, okay, because some of the string above and below this pulley is going to get shorter. The total amount shorter they have to get is a foot. They're going to share that. They're each going to get half a foot shorter, okay? So the end result is if M2 moves 1 foot, M1 only moves a half foot, okay? What that means is A1 is only 1/2 of A2, okay? Now that's not exactly physics necessarily. It's just kind of looking at the situation and kind of understanding what's going to move where and how, okay? All right, so that's probably one of the hardest parts, okay? Now, by the way, for those of you at LT who are doing problem sets, you're going to have a couple problems like this. They're hooked up slightly differently, okay? So keep that in mind. Like this is one example I'm showing you. Each example is going to be different, and you have to kind of look at each one and figure out like which block's going to move faster or slower, okay? Now, how many objects do you have moving? Well, a lot of people are going to say 2, but it turns out you have 3. You've got M1, you got M2, and you got this pulley moving. So we're going to draw FBDs of all 3. So let's start with M1. Okay, so for M1, you're going to have force of normal 1. You're going to have M1G. You're going to have this tension. I'll call it T1, all right? And then you're going to have friction. And that's mu sub K1, or I'm just going to write mu sub K times Fn1, okay? And we know that in this problem, M1's not moving up or down at all. There's no upward or downward acceleration. So Fn1 is going to equal M1G. And so friction is going to equal mu sub K times M1G, okay? And if I were to look at my acceleration, net force in the horizontal direction equals ma1, or m1a1, then I have T1 minus mu sub K m1g equals m1a1. All right, so now I've got 2 equations, okay? But I have 3 unknowns. I have A1, A2, and now I have a T1 sitting there. So I've got 2 equations and 3 unknowns, so I can't solve yet. So I need at least one more equation, okay? Well, let's look at M2. Now, for this system, I'm going to say clockwise is positive. So if I look at M2, okay, I've got M2G acting down, and then I have this red string pulling up. I'm going to call that T2, okay? And down is positive for this guy. So if I write out Newton's second law for that guy, you've got M2 times G minus T2 equals M2 A2. Okay. Now, I've introduced a third equation, but I've also introduced a fourth unknown, T2. Okay. So I need at least one more equation now. Well, the one object I haven't drawn an FBD for yet is this pulley that I've highlighted in yellow. Okay, let's draw an FBD of that. Now, we're saying for now it's a roughly massless, frictionless pulley. So what forces act on it? Well, you got T1 to the left, and you have T2 pulling on it in two different places. So there's two T2s to the right. Now, if I draw Newton's second law out, net force horizontally equals mass of the pulley times A, we're saying the mass of the pulley is roughly zero, which means the net force has to be roughly zero. So what does that mean about our tensions? Well, that means that T1 has to about equal 2 T2s, okay? So T1 has to equal 2 T2s, all right? Now you've got it. You have four equations with four unknowns, A1, A2, T1, and T2, okay? At this point, if you're trying to find any one variable, you would do a series of substitutions. I'm not going to belabor the algebra here, but you could do a series of substitutions and eventually solve for whatever variable you were wanting to solve for. Also, at this point, they might give you numbers, in which case, and it might even be easier to plug numbers in at this point. So again, when you have a pulley system, think very carefully about how the length of the string is changing, how the pulleys are moving, and how the accelerations of the different objects relate to each other before you start trying to write out Newton's laws and trying to solve for the tensions and accelerations and forces and so on. So I hope that example was helpful, and thank you very much.